Great.
Hello, I'm Sienna Burke.
I'm Ashley Sexton.
I'm Vishwa Silva.
I'm Vizay.
And today we're going to be talking to you about classifying queries based on the National American Products Classification System, or NAPS. So a little background information. This information was given to us by our industry liaison, Ms. Elizabeth Love from the U.S. Census Bureau. And to start, NAPS is a hierarchical classification system that contains goods and services and products, and is currently used in the United States, Mexico, and Canada. This database contains over 2,000 categories and several subcategories, and every 5 years the U.S. Census Bureau sends out this survey to vendors all over North America to classify every single type of item that they sell. And this is an example of the NAPCS structure. So as you can see in this example over here, you have your larger categories which have smaller numbers because they encompass a lot more. But as you get more and more detailed, your category numbers will get larger and larger because they contain a lot less. They're a lot more specific. And that's kind of how the structuring goes. And for our algorithms, we decided to only pay attention to the smallest subcategories or the child nodes. Now, the problem is when this survey is sent out to vendors every 5 years, it can be very daunting to choose between 2,000 different products for something as simple as, let's say, tennis shoes. So, yeah, that's too many options for them. So our main goal was to create a digital word query that would allow the user to type in the item that they sell, and we would output the best categories into which that item would fit. And to do this, we use different ranking algorithms that would best match the query with the appropriate category.
So like we said, we're trying to develop different ranking algorithms. So in order to rank something, we at least need to have a numerical representation of words or queries or categories. And for that, what we are going to use is something called Word2Vec. Now, Word2Vec is a tool which computes vector representation of words. It was developed by engineers at Google. And the reason Word2Vec is so useful is not only are words represented in terms of vectors, but how they are situated or how they lie in a spatial form that gives some meaning about their context as well. So, for example, in the next slide you'll see there's something called cosine similarity, which will help you measure how close two words are, and by that you can see if the vectors are closer together, you can predict that they must be related to each other way more than they would be if they were far apart. So Word2Vec learns from a giant corpus of words. For now, we're using a pre-trained Word2Vec model, which is trained on the Google News database, which has around 10 billion words. And like I said, the cosine similarity that we're talking about, it is simply the cos of the angle between the two vectors, and that gives us a measure of how close two word vectors are. For example, from the model that we are using, if you look at some of the cosine similarity values for different words, you can see that the jeans and clothing have a cosine similarity of 0.61 because their word vectors are closer together to each other, compared to words like jeans and food, which are not related to each other, which probably explains why their cosine similarity values are less. And so, since we want to rank the different words and queries into specific categories, what we're trying to do is we're trying to do some pre-processing to make our process easier. One of the things that we do is that after looking at the NAPS structure, we found out that there were multiple categories which in the NAPS which had similar words, for example, like goods and services that are mentioned here. Those words appear throughout the categories, and they wouldn't really help us in ranking those ranking queries into sections. That's why we try to keep those words out. Similarly, we try to keep words like as, for, and, to words out of the model because it really doesn't help you in ranking those methods. And after that, we develop a numerical rank score for each category so that we can find out which category got the best numerical rank score for a particular query.
So we are going to use cosine similarity metric to do the ranking algorithms, and we have two different ranking algorithms. The first one is the average cosine similarity for a category, and the second one is maximum cosine similarity for a category. In the average cosine similarity, what we are doing is there's going to be a query, and there are going to be a bunch of words in each category. So what we are doing is we are comparing the query word with the words in the category. And in the average cosine similarity, what we're doing is we're taking the average of the cosine similarity of each query, the query word with each word of the category, and we're taking the average. And while in the maximum cosine similarity, we are just taking the best score out of those words, words in the category. So these are the two ranking algorithms. As you can see here, with the average one, with the query word genes, you can see with the first category we have a score of 0.61 because clothing is very similar, very closer to genes. While as you go down the list, in the second one, it's the score goes below it, even though there is clothing, but there are other words which brings down the score down. While in the last category, you can see narrow fabric, which I guess not very similar to jeans. That's why it has a very low score. While using the maximum cosine similarity, you can see all the scores are the same because each category has the word clothing, and that is the I think that is the closest word to the jeans, and that's giving us the maximum score. So these are the two ranking algorithms we are using. Biso is going to show you a demo where he puts the query, and you can see the results.
So this is the web application that we created to rank the different categories for a certain query, and let's just take a look at how this works. So we type in any word, let's say apple, and then so it gives you a list of it classifies your different categories and gives them a rank score. So if you look at it, most of these categories look like they are related to fruits or some kind of like something to eat. I think this one would probably be the best class category for the query. And this is what we get from a first ranking method, whereas from the second ranking method, you can get some. These are the categories that you get. Thanks.
So in conclusion, we're using these two ranking algorithms to create a very accurate classification of these different words and phrases that will be used for the NAP system. Our methods are very computationally cheap because the systems we are using, we don't have to train anything. We're using models and data sets that have already been formed, and there's nothing that we are having to train on our end of the deal. Going forward, some of the further work that we could do with this project would be to further train this model by web scraping, using data from the different vendors that the NAP system receives information from, and using their language and their lingo for their different products to further increase the efficiency of our model and our program. Another way we can improve this and go further would be comparing word2vec to other vector representations such as love. We can also use various similarity measures such as Euclidean distance or Hamming distance. And then lastly, we could also experiment with other ranking methods such as the K-max average. We'd like to thank the PIC-MATH program for just funding us the MAA and SIAM to allow us to have